the last session we have seen the potential energy. We have seen the P is given as minus G capital M small m upon R plus H. Today we learn about escape velocity. To calculate the escape velocity, we are going to take the help of equation of potential energy. म्हणून हे आपण आधी शिकलेलो आहे. Let us go back to Newton's kinematic equations. आपल्याला माहिती आहे, suppose this is the earth surface. This is the earth surface. If we throw an object upward with velocity u, right? Now what is this u? U is initial velocity. As this object goes up, हा एखादा ऑब्जेक्ट खालून पृथ्वीवरून आपण सरफेसवरून वर फेकला, तर it will go to a certain height, and here its final velocity will become 0 and it will fall down. its velocity काय होत जाणार? So u will go on decreasing, right? Then we can write down the velocity will go on decreasing as it goes up. As it goes up, its velocity u काय होत जाणार? u काय होत जाणार? कमी कमी होत जाणार. Why u will go on reducing? u कमी का होणार? Because gravitational acceleration in opposite direction up due to gravitational acceleration acting in opposite direction of velocity. Opposite direction of velocity. बरोबर ना? हा u वर टाकला, g is acting downward, g is a gravitational acceleration due to gravity, so naturally the velocity will go on decreasing. For example, if this is a 10 meters or let us say 100 meters per second, जसा जसा हा ऑब्जेक्ट वर जाणार, ही velocity काय होत जाणार? कमी 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 होत जाणार, and at a certain level it will become, velocity will become 0 and the object will fall down. And this is given by kinematic equation v square is equal to u square plus twice gs, right? But here the g is negative and final velocity v is equal to 0. Final velocity v is equal to 0. So we know that 0 is equal to, this is a u square minus 2gs. So how much height? Yes, this is the height. So this is the height at which it will go, right? So if we take rearrange, then u square is equal to 2gs minus g का लगा तुम्हारा? G is acting downward, u vertical. Suppose if we increase the initial velocity, if we increase the initial velocity, suppose if we make it 1000, what will happen? What will happen? U जर 1000 केला, if u जर 1000 केला, so here from this s is equal to u square upon 2g. So the u जर वाढवला, तर हा ऑब्जेक्ट काय होणार? जास्त वर जाणार. कुठे जाणार? जास्त वर जाणार. Because s is given as u square. u वाढला की s वाढणार. If we make it 10,000 meters per second, let us say if I make 5,000 meters per second, the object will still go high. That means increasing the initial initial velocity, the object will go to a greater and greater height before it comes to rest. Before it comes to rest. So we can write down here. So we can write down. So we can write down. If the initial velocity u is increased, the object will reach to a greater height where before coming to rest, or at which it will come to rest and will fall down. म्हणजे काय बघा, if you increase the u वाढवला की तो खूप वरच्या हाईटला जाणार. As you go on increasing, it will go to more and more height. As it goes to height, the velocity is going to decrease. u काय होत जाणार, हा 5000 आहे, थोड्या वेळाने 4000 होणार, नंतर काय होणार 3000, नंतर 1000, नंतर 100, नंतर 10, नंतर 0. आणि ज्या ठिकाणी 0 होणार, it will go to a very high level and it will drop down because of gravitational acceleration. So this is what is the meaning of this particular sentence. आणि हे तुम्हाला माहिती आहे, जेवढी velocity, initial velocity जास्त, तेवढा तो जास्त हाईटला जाणार. True, but we also know what is the g. G ची व्हॅल्यू आपल्याला माहिती आहे. So g is equal to capital G m upon r plus h. जर हा u आपण वाढवत गेलो, h काय होत जाणार, हाईट काय होत जाणार, वाढत जाणार. जर हाईट जर वाढत गेली तर हा g काय होणार, अरे कमी होणार. जर g कमी झाला तर ग्रॅव्हिटेशनल फोर्स काय होणार, कमी होणार. मग ग्रॅव्हिटेशनल फोर्स कमी होणार याचाच अर्थ आहे छोट्या हाईटला 50, 100, 200 किलोमीटर काही इश्यू नाहीये. बट इफ इट गोज टू 1000 kilometers, 10,000 kilometers, 100,000 kilometers, naturally the h will go on. That means planetary distance ला जर गेला, at planetary distances this h will go on increasing and the g will go on decreasing. If the g decreases, then its gravitational pull will also decrease. Gravitational pull also will decrease. आणि जर gravitational pull decrease झाला तर हळूहळू g काय होत जाणार, कमी होत जाणार. g कमी होत जाणार. And one point will come where the g is 0. Where the g, समजा आपण u वाढवत गेलो, right? So I can write down, if with increase in initial velocity and as the height goes on increasing, the value of g decreases. This is the equation. The value of d decreases. Hence, the gravitational pull will also decrease with increase in initial velocity. कुछ समझ में आ रहा है? 10 मीटर पर सेकेंड, 100, काही इश्यू नाही. 1000, 5000, if it goes beyond that, it will go to a very high height. खूप वरती जाणार. आणि ज्या हाईटला गेल्यानंतर g ची व्हॅल्यू कमी होणार. g ची व्हॅल्यू कमी झाली तर आपल्याला माहिती आहे s is equal to u square upon 2g. आता मगाशीच बघितलं आपण. As the value of g decreases, g काय होणार, जी कमी कमी होत जाणार, यू वाढत जाणार, एस काय होणार, तो खूपच जास्त हाईटला पोहोचणार. राईट? whether the g can be 0, समजा असं अश्युम करायचं g 0 झाला, the value of g becomes 0. What does it mean? It means that the value of g is 0 means that it has reached to infinity. In the last session we have seen the potential energy. We have seen the P is given as minus g capital M small m upon r plus h. Today we learn about escape velocity. To calculate the escape velocity, we are going to take the help of equation of potential energy. म्हणून हे आपण आधी शिकलेलो आहे. Let us go back to Newton's kinematic equations. आपल्याला माहिती आहे, suppose this is the earth surface, this is the earth surface. If we throw an object upward with velocity u, right? Now what is this u? U is initial velocity. As this object goes up, हा एखादा ऑब्जेक्ट खालून पृथ्वीवरून आपण सरफेसवरून वर फेकला, तर it will go to a certain height, and here its final velocity will become 0 and it will fall down. ह्याची velocity काय होत जाणार? So you will go on decreasing, right? Then we can write down the velocity will go on decreasing as it goes up. As it goes up, its velocity u काय होत जाणार? U काय होत जाणार? कमी कमी होत जाणार. Why u will go on reducing? U कमी का होणार? Because gravitational acceleration in opposite direction up due to gravitational acceleration acting in opposite direction of velocity. Opposite direction of velocity. बरोबर आहे ना? हा u वर टाकला, g is acting downward, g is a gravitational acceleration due to gravity, so naturally the velocity will go on decreasing. For example, if this is a 10 meters or let us say 100 meters per second, जसा जसा हा ऑब्जेक्ट वर जाणार, ही velocity काय होत जाणार? कमी 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 होत जाणार, and at a certain level it will become, velocity will become 0 and the object will fall down. And this is given by kinematic equation v square is equal to u square plus twice gs, right? But here the g is negative and final velocity v is equal to 0. Final velocity v is equal to 0. So we know that 0 is equal to, this is a u square minus 2gs. So how much height? Yes, this is the height. So this is the height at which it will go, right? So if you rearrange, then u square is equal to 2gs minus g कळलं तुम्हाला? G is acting downward, u vertical. Suppose if we increase the initial velocity, if we increase the initial velocity, suppose if we make it 1000, what will happen? What will happen? U जर 1000 केला, if u जर 1000 केला, so here from this, s is equal to u square upon 2g. सो जर u जर वाढवला तर हा ऑब्जेक्ट काय होणार, जास्त वर जाणार. कुठं जाणार, जास्त वर जाणार. बिकॉज s इज गिवन इन u स्क्वेअर. u वाढला की s वाढणार. If we make it 10,000 meters per second, let us say if I make 5,000 meters per second, the object will still go high. That means increasing the initial velocity, the object will go to a greater and greater height before it comes to rest. Before it comes to rest. So we can write down here. So we can write down. So we can write down. If the initial velocity u is increased, the will reach to a greater height where before coming to rest, or at which it will come to rest and will fall down. म्हणजे काय बघा, if you increase the u वाढवला की तो खूप वरच्या हाईटला जाणार. As you go on increasing, it will go to more and more height. As it goes to height, the velocity is going to decrease. u काय होत जाणार, हा 5,000 आहे, थोड्या वेळाने 4,000 होणार, नंतर काय होणार 3,000, नंतर 1,000, नंतर 100, नंतर 10, नंतर 0. आणि ज्या ठिकाणी 0 होणार, it will go to a very high level and it will drop down because of gravitational acceleration. So this is what is the meaning of this particular sentence. आणि हे तुम्हाला माहिती आहे, जेवढी वेलॉसिटी, इनिशियल वेलॉसिटी जास्त, तेवढा तो जास्त हाईटला जाणार. True, but we also know what is the g. G ची व्हॅल्यू आपल्याला माहिती आहे. So g is equal to capital G m upon r plus h. जर हा u आपण वाढवत गेलो, h काय होत जाणार, हाईट काय होत जाणार, वाढत जाणार. जर हाईट जर वाढत गेली तर हा g काय होणार, अरे कमी होणार. जर g कमी झाला तर ग्रॅव्हिटेशनल फोर्स काय होणार, कमी होणार. मग ग्रॅव्हिटेशनल फोर्स कमी होणार याचाच अर्थ आहे छोट्या हाईटला 50, 100, 200 किलोमीटर काही इश्यू नाहीये. बट इफ इट गोज टू 1000 किलोमीटर्स, 10,000 kilometers, 100,000 kilometers, naturally the h will go on. That means planetary distance ला जर गेला, at planetary distances this h will go on increasing and the g will go on decreasing. If the g decreases, then its gravitational pull will also decrease. Gravitational pull also will decrease. आणि जर gravitational pull decrease झाला तर हळूहळू g काय होत जाणार, कमी होत जाणार. g कमी होत जाणार. And one point will come where the g is 0. Where the g, समजा आपण u वाढवत गेलो, right? So I can write down, if with increase in initial velocity and as the height goes on increasing, the value of g decreases. This is the equation. The value of d decreases. Hence, the gravitational pull will also decrease with increase in initial velocity. कुछ समझ में आ रहा है? 10 मीटर पर सेकंड, 100 काही इश्यू नाही, 1000, 5 beyond that. It will go to a very high height. खूप वरती जाणार आणि ज्या हाईटला गेल्यानंतर जी ची व्हॅल्यू कमी होणार, जी ची व्हॅल्यू कमी झाली तर आपल्याला माहिती आहे S is equal to u square upon 2g. आता मगाशीच बघितलं आपण. As the value of g decreases, g काय होणार? g कमी कमी होत जाणार, u वाढत जाणार, s काय होणार? तो खूपच जास्त हाईटला पोहोचणार. Right? Whether the g can be 0, समजा असं assume करा जर g 0 झाला. The value of g becomes 0. What does it mean? It means that the value of g is 0 means that it has reached to infinity. If the denominator is 0, denominator is infinity, then the g value will become 0. So suppose if you increase the u, that means initial velocity such that it goes to infinity, where the g will be 0, and the object will never come back on earth. Is it not? Just imagine, if I start increasing the initial velocity, वर फेकला, खाली पडला. I increase it more, it has gone up, still fall down. If I increase more, if I increase to height, let us say 1,000 kilometers, 2,000 kilometers, then the g काय होत जाणार? कमी होत जाणार because height is increasing. The g will go on decreasing, the gravitational pull will go on decreasing. आणि मी समजा u आणि वाढवला, इनिशियल व्हेलॉसिटी आणि वाढवली, तर तो आणि हाईटला जाणार आणि इट विल रीच टू इन्फिनिटी. ज्या ठिकाणी तिची व्हेलॉसिटी काय होणार? 0 होणार. तिथून तो खाली परत येईल का? नाही येणार. Why it will not come? कारण at infinity the h will become infinity, the g will become 0, and if the g is 0, then gravitational pull will be 0, and it will never fall back. And that initial velocity, when it will never come back to Earth or the planet, is called as escape velocity. कुछ समझ में आ रहा है? It is that initial velocity, escape velocity is that initial velocity. If you give to that object, it will reach to infinity, or it will come to rest at infinity, and it will never come back to Earth because the gravitational acceleration at that point will become 0. So let us write down here. Escape velocity, लिहून घ्या. Escape velocity is the initial velocity of the object on Earth. On Earth, you कुठं आहे? On Earth आहे लक्षात ठेवा. You on Earth, such that the object will reach to infinity, or the object will come to rest, means v will be equal to 0 at infinity, where the gravitational acceleration इथं जर इन्फिनिटी आलं तर काय होणार आहे? g will become 0, where the gravitational acceleration will be 0, and consequently the gravitational pull will be 0, and the object will never return back to Earth. it is such initial velocity that it will reach to infinity, and where at infinity the velocity will become zero. Infinity तो काय होणार? Zero होणार. Infinity ला velocity मिळणार नाही. जर u पेक्षा जास्त velocity दिली तर infinity ला पण velocity zero च्या पेक्षा जास्त असणार आहे. So it is that initial velocity, it will reach to infinity, it will come down to rest at infinity, and the gravitational pull will be zero, and it will never come back on the earth. And that such initial velocity is called as escape velocity. In other words, the energy due to its velocity will overcome the gravitational pull. Will overcome the gravitational pull. In other words, the energy due to energy u आहे, u is such that it will overcome the gravitational pull, and that is called as the escape velocity. Now we do the calculations of escape velocity. We do calculations of escape velocity. So the calculations of escape velocity. Calculations of escape velocity. ये ध्यान क्या? So for this we are going to take help of the law of conservation of energy. So law of conservation of energy. तुम्हाला लॉ माहिती आहे का? कंजर्वेशन ऑफ एनर्जी. एनर्जी शब्द ऐकलाय? येस, ऐकलं आहे तुम्ही. What the law says? Law says that the energy cannot be created, nor it is destroyed, but it can be converted from one form to another form. म्हणजे एनर्जी आपल्याला नवीन तयार करता येत नाही. एनर्जी आपल्याला घालवता पण येत नाही, नष्ट पण करता येत नाही, पण एनर्जी एका फॉर्म मधून दुसऱ्या फॉर्मला आपण कन्वर्ट करू शकतो. So what is that law? Let's understand. It states that, you write down, it states that the energy cannot be created nor destroyed, but it can be converted from one form to another form. कोणते कोणते फॉर्म्स आहेत तुम्हाला माहिती आहेत ना? आपण आता बघणार आहोत इथं another form. And we can write down or we can write down the two. कोणते कोणते फॉर्म आहेत तुम्हाला माहिती आहे? We'll write down also. The total energy remains constant. म्हणजे total energy ही constant आहे. And we can interchange the energy, but we cannot create energy, cannot destroy energy. That is more important. आता ज्याप्रमाणे तुम्ही you have learned potential energy, and that you know mgh for smaller values, or in case of planetary, now we learn planetary, that is equal to minus g m into m upon r plus h. This is a potential energy. There is another form of energy, and that is called as a kinetic energy. Do you know kinetic energy? Kinetic energy it is the energy possessed by virtue of speed of an object. Speed of an object. एखाद्या ऑब्जेक्टला स्पीड असणे म्हणजे त्याच्यामध्ये एनर्जी आहे. फॉर एक्झाम्पल, एक छोटासा दगड घ्या, छोटासा दगड, आणि तुम्ही तो दगड असा कोणाला तरी मारा, टक मारा, हळूच मारा, लागेल का त्याला? नाही लागेल. पण तो छोटा दगड जर बंदुकीमध्ये घातला आणि जर ट्रिगर केला तर तिची व्हेलॉसिटी, त्याचं स्पीड वाढणार, आणि त्या स्पीड वाढल्यामुळे एखाद्याचा मृत्यू होऊ शकतो. मग या दोन्ही केसमध्ये काय फरक आहे? मास ऑफ दॅट स्टोन इज सेम, द ओनली चेंज इज स्पीड. त्याचं व्हेलॉसिटी वाढलेली आहे. म्हणजे एखादा छोटा जरी ऑब्जेक्ट जरी आपण जास्त व्हेलॉसिटीने स्पीडने जरी फेकून मारला तरी इट कॅन कॉज डॅमेज, कारण इट हॅज गॉट एनर्जी, अँड दॅट एनर्जी इज कॉल्ड एज अ कायनेटिक एनर्जी बाय व्हर्च्यू ऑफ स्पीड ऑफ एन ऑब्जेक्ट. आणि ही किती दिलेली आहे? दिस इज गिवन ॲज 1/2 mv², where इथं v is equal to speed, m is equal to mass of the object. So these are the two energies associated with an object. तर प्रत्येक ऑब्जेक्टला दोन आहेत. If it is a height, it has got a potential energy. If it is a height, it has got a potential energy. If it's moving with a velocity, it has got a kinetic energy. जसा वर जाणार तसे तिची पोटेन्शियल एनर्जी काय होणार? वाढत जाणार. Of course we have learned, as it goes up, its potential energy काय होणार? वाढत जाणार. As it goes up, its velocity will decrease or increase? It will decrease. If the velocity decreases, its kinetic energy will go on decreases. So if we throw an object from Earth's surface up in the space, its potential energy will go on increasing and its kinetic energy will go on decreasing. So, and the total energy, I'll write down, total energy, that is equal to PE plus K. P plus K. This is a P, this is a K. And this is called as mechanical energy. So mechanical energy ला दोन components आहेत. One is the potential energy because of the height, and another is kinetic energy because of its velocity or speed. And sum of these two is called as the mechanical energy. And mechanical energy of any object or the total energy of an object remains constant. This is according to the law of conservation of energy. म्हणजे total energy जर constant असेल तर PE can be converted into KE or KE can be converted into PE, but the sum of these two should remain constant. That is the law of conservation. मला वाटतं तुम्हाला कळतंय ही टोटल एनर्जी कॉन्स्टंट आहे. पी वरनं की होऊ शकतो, के वरनं पी होऊ शकतो, किंवा इट कॅन हॅव बोथ. ऍज इट गोज अप द पी इज इन्क्रीजिंग, द के इज डिक्रीजिंग. At intermediate stage there is a key, there is a PE also. So you can write down here, if an object is thrown in space with an initial velocity, its PE will increase and PE will go on increasing, and KE will पण जसं वर जाणार तशी त्याची व्हेलॉसिटी काय होत जाणार, कमी कमी होत जाणार. करेक्ट. जर व्हेलॉसिटी जर कमी झाली तर कायनेटिक एनर्जी काय होणार, कमी होणार. आणि जसा वर वर हाईटला जाणार ही मायनस आहे, एच वाढत जाणार, ही व्हॅल्यू कमी कमी होत जाणार, म्हणजेच पोटेन्शियल एनर्जी ही वर जाणार तशी वाढत वाढत जाणार. बट sum of Ke plus Pe will remain constant. This is more important. Sum of Ke plus Pe will remain constant. But the kinetic energy can be converted to potential energy. Potential energy can be converted into kinetic energy. That you will study in 11th and 12th in more details. But we should know the sum of this is constant according to the law of conservation of energy. So, now, लिहून घ्या. Suppose now, what is escape velocity? Escape velocity is such that, let us say this is Earth's surface. Here, this is object here, we are throwing with initial velocity u, and this u is we are calling as the escape velocity. That is what we are doing. So on the surface, what is the value of P? So first, P on surface of Earth. P on surface of Earth. Here the H is equal to G. So P on Earth on surface. So P is the formula क्या है, minus G m upon R plus H. आपने शिकला. So this is m is equal to mass of the object. Mass of object. R plus H. So H is equal to 0. So P at surface. So this is equal to minus G m into m upon P on surface of the Earth. So what is the P here? So we got the P minus G m upon. Second, K on surface of Earth. So K is given as 1/2 m v square, and again v is equal to u escape. U escape. Allow me escape म्हणतो. U escape. So this is equal to 1/2 m u escape. So this is equal to G. So what is the K here? 1/2 m u escape square. So third, total energy on surface of Earth. So that is equal to how much? So that is equal to, that is we call the mechanical energy. That is equal to P plus K. So if I add that, then I'll get 1/2 m u escape square minus G into m upon R. This is the total energy. Surface. Sum of this one. So total energy is sum of this one. Right? Now, I hope you understand. At the Earth's surface, the height is equal to 0, so H is equal to 0. The potential energy from center of the Earth, we are taking from center of the Earth because that is more important. So minus G dot m into m, where m is the mass of this object upon R. Kinetic energy. We are throwing this object with initial velocity u escape such that it will reach to infinity. So 1 half mv square, v is equal to u escape sub square, so this is kinetic energy. So the total energy of this object here, because of the height, potential energy, because of the velocity, kinetic energy, so total energy is sum of P plus K, that we call as the mechanical energy, so we have added these two. Now, this object goes to infinity. At infinity, right? So this is the infinity. Height can be, so here the h is equal to infinity. H, or I can say here r plus s, that is 2. H is equal to infinity. And when it reaches to infinity, it will come to rest, so its final velocity will become 0. Upon u, u is such initial velocity, it will go beyond the gravitational pull. That means where the g will be 0, ज्या ठिकाणी gravitational acceleration 0 होईल आणि gravitational acceleration 0 कुठे होणार आहे इन्फिनिटीला, म्हणजे it will go to infinity, 0 होणार, त्या ठिकाणी velocity 0 होणार. So now we can calculate here. So it's the second is that P or 1, 2, 3, I can write on the fourth, P at infinity, म्हणजेच h is equal to 0. So P is the formula आपल्याला माहिती आहे minus g m into m upon r plus h. H is equal to 0. So this is going to be minus g, or I'll write down here. So it's minus g m, this is the capital M dot m upon r plus infinity. So this is equal to 0. So P is equal to 0. We got this answer. This is what we have done. इथे किती आहे minus आहे. Surface ला किती आहे minus. So here we'll get P is equal to 0. Second, let us calculate the fifth is the kinetic energy at infinity. When it reaches to infinity, the velocity becomes 0. So at infinity, v is equal to 0. So K is equal to 1 half mv square, and that is equal to 0. Because if the v is 0, the kinetic energy is also 0. So here the Ke is also 0. So at infinity, velocity is 0. So kinetic energy is 0. At infinity, the P is equal to 0 because the denominator becomes infinity. The value of P becomes 0. And the total energy at infinity, that we call it the mechanical energy, and that is equal to Ke plus P, and that value is equal to 0. So at infinity, the total energy of this one is equal to 0. The total energy is equal to 0. So the initial energy was at surface was 1 half mu square plus minus g mm upon. Here we can say, I'll say simply energy. It's a mechanical energy, but I'll say E, connect the E level. The total energy was this much. Now the total energy is this much. So according to law of conservation of energy, the energy remains constant. So we can write down, so according to, so हे तो मतलब पुस्तक में इतना है, I don't know here. So, according to law of conservation of energy, initial energy is equal to final energy. Energy बदलणार नाही. Initial energy जेवढी आहे तेवढीच final energy होणार. So we can write down. So So this is at surface and this is at infinity. So we can write down 1/2 mu escape velocity to the square minus g capital M into m upon r is equal to 0. So we can take, now we can rearrange. So if you rearrange now you can do it yourself. So it's a 1/2 mu escape to the square and that is equal to g into m upon r. So m ने m को मार दिया. So u square escape is equal to g m. हा 2 घेतो मी इकडं. I'll take this 2. So 2 g m upon r. Okay, लिहून घ्या. I'm going to rub this one. This also I can write down. So I can say multiplying. So here I will multiply r here and r here. वर r ने multiply केलं, खाली r ने multiply केलं. So the value will not change. So u escape the square is equal to 2 into g into mr upon r square. पण gm upon r square म्हणजे काय आहे? gm upon r square म्हणजे काय आहे? gm upon r square, but g into m upon r square is equal to g on earth. Is it not? It's the value of g on earth. G the formula काय आहे? G the formula आहे g into m upon r plus h bracket square. The h is equal to 0 at surface. So g on surface. So we get, so u square escape velocity will get 2. This value will become g into r. So u escape is equal to under root 2g. So this is the formula for escape velocity. This is the equation for, so this is the this g is the acceleration on the surface of the planet here on the earth. R is the radius of the planet or earth, and accordingly we can calculate the escape velocity. या व्हॅल्यू टाकल्यानंतर जी काय velocity मिळणार त्या velocity if we throw an object up in the sky, it will go up such that it will reach to a height where it will not come back to the planet because the gravitational acceleration, the gravitational force at that point will become 0. And that point is called as the infinity, and at infinity the velocity of the object will become 0. So now we have got the equation of escape velocity, and that is equal to under root 2g into m upon r. This is the basic equation, right? And if we multiply the numerator by r and denominator by r, we get the value 2 under 2g into m into r upon r square. पण आपल्याला माहिती आहे gravitational acceleration g is equal to gm upon r square. This is g at the surface of the planet or the earth. So I can put this value for this particular term as g. Then I'll get the v escape under 2gr. So this is how we got the equation using a law of conservation of energy. Now for earth, right? For earth, g is equal to how much? That is equal to 9.80 meter per second square. And radius of the earth is equal to 6400 kilometer. This is nothing but 6400 into 1000 meters. And this value comes to be 1, 2, 3, 4, 5, 6. I'll put a stop here. So 6.4 into 10 raised to 6 meters. So this is a radius. काही लास्टच्या सेशन मध्ये I have taken 6.4 into 10 raised to 5, which I made a mistake. You can correct that. The right radius is 6.4 into 10 raised to 6 meters. This is in kilometers. So we can put this value here. So V escape is equal to under root 2 into 9.8 into 6. I'll take on this side so that you can, or you can write down. Okay. V escape is equal to under root 2 into 9.8 into 6.4 into 10 to 6. So if you calculate this, it will become 11.2 into 10 raised to 3 meters, and that is meters per second, and that is nothing but 11.2 10 to 3 meters, which is kilometers per second. So the escape velocity of any object, on Earth's surface, because 9.8 is g for Earth, radius is for Earth, is 11.2. So you can write down the escape velocity for an object on Earth's surface is 11.2 kilometers. You have a feeling about 11.2 kilometers per second. 11.2 is not meter per second, it's kilometer per second. Kilometers. Just imagine Mumbai to Bangalore. So this is a Mumbai. एक feel घेऊया आपण त्याचा. Mumbai to Bangalore. This distance is around 1,000 kilometers. Is around 1,000 kilometers. If you had to go by aeroplane, it takes, for this travel, it takes 1.2 hours on travel, 1.2 hours, and for this one, if you say 11.2 kilometers, it is just 90 seconds. It is just 90 seconds. म्हणजे तुम्ही जर रॉकेट जर लॉन्च केला तुम्ही मुंबईतून, if you launch a rocket from Mumbai at the speed of 11.2 km escape velocity, then it will reach to Bangalore within 90 seconds. Within 90 seconds. So you can imagine how fast it is. So this is the speed or the velocity required. When we calculated this velocity, the formula is under root 2 gr. याच्यामध्ये मास कुठं आहे का? याच्यामध्ये मास कुठं आहे का? Mass of the object आहे का? नाही आहे. There is no mass of the object. क्या कुठं आहे का mass of the object? नहीं है. So it is independent of. So it's independent of escape velocity. V escape is independent of mass of the object. म्हणजे object 1 kilo असू दे किंवा 1000 kilo असू दे. Whatever the size may be, whatever the shape may be, whatever may be the mass of the object may be, the escape velocity will remain the same. म्हणजे मोठं रॉकेट पाठवायचं आहे एवढीच पाहिजे velocity. छोटं रॉकेट पाठवायचं आहे एवढीच velocity पाहिजे. So that is the meaning. So it's independent of the escape velocity. So let us have feel of this one again. समजा we are on Earth surface. Now we want to send it to a place. So here we call as the height h is equal to infinity. H is equal to infinity. So here you have to launch with u escape, it will go here and it will, here the velocity will become 0. It will not go here. It will not. So it will stop here. It will stop. In infinity, it is a distance where the gravitational pull is not sufficient to bring back the rocket, the object, back to the earth. It depends upon, so V escape depends upon what? It depends upon, if you use this formula, it depends upon the mass of the planet, radius of the planet. This is a constant. So it depends on mass and radius. That means properties of the planet. Properties of the planet. Not on the mass of the object. If you use this formula, then it depends upon gravitational acceleration of the planet. Both are the same formula, we are just converted. If the escape velocity is greater than 11.2, what will happen? जर escape velocity जर 11.2 पेक्षा जास्त असेल तर काय होईल? तर हे जे आहे हे gravitational pull च्या पुढे जाऊन इथं काय असणार आहे? V is equal to 0, G is equal to 0. So if U escape is greater than 11.2 kilometer per second, it will go up. It will move in the space. It will move, it will go. So the object will travel in space. If the U escape is greater than 11.2, the object will not stop here, it will travel because in the space. If U escape is equal to 11.2 kilometers per second, the object will stop at, the object will come to rest at infinity. And if V escape is less than 11.2 kilometer per second, then the object will fall down. The object will fall down. So this will be the situation. I hope you understand the escape velocity, how we have calculated. ह्याच्यावरचे न्यूमेरिकल्स विचारले जातात. एक सिंपल न्यूमेरिकल तुमच्या बुक मध्ये आहे, ते लिहून घ्या and you can do that question at your home. You can calculate. So प्रश्न काय आहे बघा. There is an exercise. There is a numerical. Find escape velocity on moon. असं विचारलं आहे. And mass of the moon and radius of moon is given. Mass of the moon is given as 7.34. Let me check it up. 7.34 into 10 raised to 22 kg. That is the mass of the moon that is given, and radius is 1.74 into 10 raised to 6 meters. Into 10 raised to 6 meters. So this is homework for you. At the same time, there is exercise at the end of the topic gravitation on the page number 14. Solve exercise on page number 14 and 15. So that is the end of the gravitation